My name is Shivendra Pandey. And, along with my virtual assistant Brian, who is the voice of this presentation, we bring you a short informative lesson. So, sit back, relax, and let us start. It is highly recommended to take notes and read further on these topics at your leisure, to brush up on what you are going to learn today. Today's topic will be on gas lift systems, where we will touch upon classification of gas lift systems, classifications of gas lift installations, categories of wells and gas lift systems, subsurface components of gas lift system, surface equipments for gas lift wells, gas lift mandrel, configuration of gas lift wells, gas lift valve, selection of proper gas lift valve, and design of a continuous gas lift system. Let us start with classification of gas lift systems. There are broadly two methods of gas lift. A. Continuous gas lift. And B. Intermittent gas lift. Continuous gas lift. In continuous gas lift, continuous volume of high-pressure gas is introduced into the tubing, to aerate or lighten the fluid column, until reduction of the bottom hole pressure allows a sufficient differential across the sand face, causing the well to produce at the desired rate of flow. Intermittent gas lift. It consists of injecting high-pressure gas into the tubing, at sufficient volume and pressure to lift the fluid head, accumulated above the valve, to the surface with maximum velocity for a short period, in order to minimize aeration and fluid fall back. Next up, classifications of gas lift installations. A. Open installations where the tubing and annulus are open to each other, no packer is used. B. Semi-closed installations where the tubing and annulus are connected only through the gas lift valves, packer is used. And C. Closed installations where a standing valve is set in the tubing, closing off flow from the tubing to the formation. Next up, categories of wells and gas lift systems. It defines where above classifications have to be used. A. High PI and high BHP wells, mainly uses semi-closed continuous gas lift system. B. High PI and low BHP wells, mainly uses closed intermittent gas lift system. C. Low PI and high BHP wells, mainly uses semi-closed intermittent gas lift system. D. Low PI and low BHP wells, mainly uses closed intermittent gas lift system. Next up, surface equipment for gas lift wells. Surface equipment for the gas lift wells mean the kind of equipment installed on the gas injection line leading to a gas lift well. For continuous lift well, two equipment are required. One is the adjustable or fixed choke to regulate the volume of gas injection. The other is the pressure controller to be fitted upstream of the choke to regulate the upstream pressure. For intermittent lift, it is a usual practice to install a time cycle controller. This controller periodically opens and closes by itself with the preset time and so periodically injects gas into the tubing. So, a time cycle controller has two basic functions. One is idle period of the cycle or time between two injection cycles like 15 minutes, 20 minutes, 30 minutes, 40 minutes, 1 hour, so on, when it will be closed and there will be no injection of gas in the well. The other is the injection time, say 1 minute, 1 minute 30 seconds, 2 minutes, 2 minutes 15 seconds, 2 minutes 30 seconds and so on. With the shortest possible injection time, the required volume of gas should flow into the casing. The time cycle controller operates with the pilot pressure of 25 pounds per square inch to 40 pounds per square inch, which is obtained either by tapping the injection line gas with pressure-reducing equipment or from compressed low-pressure air line. Next up, subsurface components of gas lift system. There are two main subsurface components of gas lift systems. These are gas lift mandrel and gas lift valve. Gas lift mandrel. Gas lift mandrel is the port of tubing string. It houses the gas lift valve and check valve. The mandrel's length ranges from 4 to 8 feet depending upon the length of the gas lift valve and check valve. There are two general types of mandrels in use, one for conventional or for fixed valve and the other is for wireline retrievable valves. In the conventional mandrel, gas lift and check valves are fitted onto the exterior side of the mandrel with the valve attachment lugs. In wireline retrievable mandrel, the gas lift valve is housed inside instead of being onto the outside. The outer shape of mandrel's tubing body looks oval-shaped with its eccentric end having box tubing connections. It has a pocket welded inside it in the eccentric portion, which is intended to house the gas lift valve. The pocket has drilled holes to connect the pocket bore with the tubing, that is, with the mandrel, and separate drilled holes to connect with the inside of the tubing. The eccentric form of the mandrel is required to ease the wireline job for the selective setting and retrieval of the gas lift valve. Gas lift valve. A gas lift valve has 5 basic components. They are: 1. Body. 2. Loading element. 3. Responsive element. 4. Transmission element. And 5. Metering element. It's very important to do a selection of proper gas lift valve. Unbalanced, bellows-operated nitrogen charged, with bigger port viz 7/16 of an inch, 3/8 of an inch, 1/2 an inch and 5/16 of an inch can be preferred for intermittent gas lift. Unbalanced, bellows-operated nitrogen charged, with smaller port opening viz 1/8 of an inch, 3/16 of an inch and 1/4 of an inch can be preferred for continuous gas lift. However, where because of the high volume production, greater port area is required, the gas lift valve of the required port area larger than 1/4 of an inch should be utilized. Unbalanced nitrogen, charged, bellows operated with spring, can be used for continuous lift wells, where production to be obtained is moderate and when well temperature is very high with high geothermal gradient. For high volume of production, this is again not suitable. For dually completed wells, tubing pressure operated valves are certainly better. With unloading valves as tubing pressure operated and the operating valve for both the string as casing pressure operated valves are a better proposition. Though, many a times casing pressure operated valves are preferred for dually completed wells. Now we come to the last concluding topic. Design of a continuous gas lift system. On graph paper, set the y-axis to depth and the x to pressure. Plot the bottom hole pressure point at depth, using the static gradient of the fluid. Plot a pressure versus depth point up the hole. Connect these points and extend to the y-axis, this is the static gradient line. Using the PI of the well, plot the PWF for the desired production rate. From this point draw a line that is parallel to the static gradient line. This is the flowing gradient line. Draw a line from the surface casing pressure on the top of the graph through this point. Where this line intersects the flow gradient line, is the depth that the casing and tubing pressures are equal. Assume a delta P across the valve of 100 pounds per square inch, find the depth that has a 100 pounds per square inch difference in these two lines, and that is the depth that the valve is set. With this we conclude our session. Hopefully it was an informative topic for you all, and you liked it. Until next time, it's goodbye from your host, Shivendra Pandey, and hope to see you in next small bite session. Till then, stay safe and keep learning.